Hi all, so today we are going to see another application of trigonometry in height and distance. So what is a height? So height, as we know, height is a measure in a vertical distance. Height is a measure of vertical distance. What this mean? This means for any object we measure its vertical distance from base to top. So let's say this one is one pillar. This is a pillar. So from its this is its base and this is top. So what is the this distance from base to top? This vertical distance, the base from base to top, it called as a height. So this is called a height, distance from base to top. What is distance? So distance is means like one distance we measure one with respect to another point, like how far one point to the another point. So like there's a point A and there is another point B. So we have to see how far A from B, and that will call the distance. Mostly we'll see in the horizontally like but let's see means how far A from B. So let's see few terminology which we use it. So first thing, the line of sight and horizontal line. So line of a sight is a straight line from observer eyes to which it is viewed, and horizontal line is horizontal line from the observer eye. What this mean? Okay, so let's say let's say you are this is you a man, which is this is you or me, and this is a aircraft which is flying in the sky. Okay, this is aircraft flying in the sky. Okay, so from my eyes, so this I am observer and this is the object which I will view. So from my eye I will draw a straight line. Okay, horizontally. So that is called the horizontal line. So this is a horizontal line. Okay, this is the horizontal line. Okay, this is the horizontal line. I draw it. Okay, so this is horizontal line. From my eyes, observer eyes, we draw a horizontal line, a straight horizontal line, and that will call the horizontal line. And what is the this line of sight? So from the observer eyes, we draw a straight line to the object which is being viewed. So this is a flight which is we are viewing it. So from our eyes, we draw a straight line to that object, that flight, and that is called the line of sight. So this is the line of sight. Okay. So this is the line of sight. So these 2 points are clear. Before we move, let's erase it. So another point is called angle of elevation and angle of depression. So angle of elevation is angle formed between a line of sight and horizontal line if object is above the horizontal line. So or angle of depression is angle formed from the line between the line of sight and horizontal line if the object is below the horizontal line. What this mean? Let's see with the help of one diagram, we'll clear it. So same example, you are a viewer, you are observer, and there is an aircraft or is flying it. So from eyes we draw a straight line that is called the line of sight. Okay, so this is called the horizontal line. Sorry. And from the point object which is viewing, this is called aircraft in our case. So we draw a straight line from to this one from our eyes. So this is our line of sight. So this object is ever above the horizontal line. The object which are viewing is above the horizontal line. So the angle made between this one, made between the horizontal line and the line of sight, this one is called the elevation, angle of elevation. Okay. Okay, this is angle of elevation. But suppose you are viewing something, let's say fish. You are standing near the river and you are viewing a fish. This is a fish. You are viewing it. So this is your horizontal line, and the object you are viewing is below the horizontal line. And the line of sight will remain the same. We just draw a straight line to this one. And then the angle, this angle we are making it, this is called the angle of depression. So you see, this is the because the angle made as for a definition, the angle made between horizontal line and the line of sight. If the object is below the horizontal line, this is called the angle of depression. So angle of depression will be this one, the angle of depression. Okay, so I think this I think with this we clear it, what is called line of sight, what is called horizontal line, what is angle of elevation, and what is angle of depression. Next we see few some basic trigonometry which we use it. Okay, so basic trigonometry, let's say we have a right angle triangle. Okay, basically in triangles, so we have a right angle triangle. Okay, and this is the 90-degree we know, and this is the angle which is mid theta. Okay, we all know. So this in this right angle triangle, this is called the perpendicular, this is called the base, and this is called the height. We know it. So the relation between perpendicular and the hypotenuse, this hypotenuse, perpendicular and hypotenuse, h is can be expressed in terms of sine theta. So sine of theta is equal to perpendicular by hypotenuse. The relation between base and hypotenuse can be expressed using a cos theta. So cos of theta will be base by height. Okay, okay. Sorry, hypotenuse, not a height. It's a hypotenuse. Okay, and that the relation between base and perpendicular and base can be expressed by the tan theta. So tan of theta will be perpendicular by base. Okay, this is a basic property, we have to use it. Another thing we see it that tan theta can be written as in form of sine and cos, that is sine theta by cos theta. Okay, this we have to we can know it. Another you we just take this hypotenuse chi square is equal to perpendicular chi square plus base chi square. Okay, so I think with this we'll use these things in our course by solving this problem. So let's say we'll see a few problems. First problem is the angle of elevation of a ladder leaning against a wall is 60 degree and the foot of the ladder is 4.6 meter away from the wall. The length of the ladder is, so we have to find the length of the ladder. So what is saying that this is saying that you have a wall, so this is your wall, and wall always will on land, so this is the land, and you have leaned your ladder, this is your ladder, let's say this is your ladder. So this is your ladder, let's say, so ladder, so this is your ladder, and you lean your ladder against a wall. So saying that it's a, when you lean it, it's from the wall, it's a 4.6 meter away. So this is your 4.6 meter. Okay, and leaning against the wall is 60 degrees. So when you lean it, it making an angle of 60 degree. Okay, so this is your theta. So you have to find the length of the ladder. So if you see, this is the your perpendicular, as we saw it. This is your this is your hypotenuse, and this is your base. So this is your base. So we have to basically given this one, we have given theta, we have to given we have to find hypotenuse. So if you remember, the relation between base and hypotenuse can be expressed using the cos of theta. So let here the cos of 60 will be base means 4.6 by hypotenuse, then cos of 60 1 by 2 will be 4.6 by hypotenuse If we cross multiply it, hypotenuse will be 2 into 4.6. So this will be 9.2. So this is your 9.2 meter answer. So this the length of your ladder is 9.2. Let's see another question. It is saying that an observer 16-meter tall is 203 meter away from a tower. So there's two things. One is observer and one is a tower. So let's draw it. So let's say this is observer and this is a tower, and saying that this is 203 meter away. So let's say the distance, because this both will be in the land only, it's a 203 meter. Okay, so let's see. Okay, the angle of elevation from his eyes to the top of the tower is 30 degrees. So angle of elevation is this one. So first, between the angle of elevation is between the horizontal line and the line of sight. So first draw the horizontal line. So from the observer eyes, this is the horizontal line, and this, and the line of sight is this one, top. He is viewing it. Okay, so he is viewing is the top. So he is viewing the top. So let's say he is viewing the top. Okay, so this one. So this is heat, given that this is 30 degree. Okay, now if you see, let's say this tower is A and B. Okay, and this observer is C and D, let's say, and it is and he is 1.6 meter tall. Okay, if you see, we have to find this length. So length of tower AB, if this is dividing at point C, will be always AB will be AC plus BC. If we just see it, and one thing, this is a rectangular. If you see CD and this is C. Okay, I have given C. Let's say E. Let's say it's a E. So A of E. Let's say it will be, so E. So it will be A of E. Okay, plus BC. So if you see this CD EB is a rectangular field, and in rectangular the parallel sides are the opposite sides are parallel. So this means that this will be equal to this one. So this EB, okay, AE and EB. For EB will be 1.6. Okay, and this CE we have to 203. So we have to only find A. Okay, so we have to find a relation between this base and this perpendicular. You see this right angle degree. So we know that relation between base and perpendicular can be found using the tan of theta. So in here, tan of 30 will be A of E divided by this 203, and we know that tan 30 is 1 by root 3 is equal to A by 203. So in this case, our A of E will be 203 divided by root of 3. Okay, so A. So here, just what we will do it. So for A we found it. So for AB will be this one, 203 divided by root 3 plus 1.6. So this will be our answer. Okay, let's see another question. Another question is, from the top of a building 60-meter high, the angle of elevation and the depression of the top and foot of the another building are alpha and beta respectively. Find the height of second building. So there are two buildings are there. So there is one building. We have one building. So we have a one building, this one, and we have another building, this one. Okay, what this and this both are will be in this one. Okay, it is saying that from the top of the building 60-meter high. So this building 60-meter high. So this is the 60-meter. Okay, so let's say this is the 60-meter. Okay, from there the angle of elevation. So for finding the angle of elevation, we need a horizontal line, because this is the angle between a horizontal line and the line of sight. So here the foot, so top. So this, if you see this one, it will the angle of elevation, and it is saying that alpha. Okay, and from here it is seeing the foot of this another building, and this will be the beta. Okay, we have to find the height of the second building. So we have to basically, we have to find, let's say it's a and it's a b, and we will find this AB. Let's say this cut in the point of C, the horizontal line cut this AC. So we can see it, AB will be AC plus BC, plus CB. Okay, anyway, you can write CB, anything. So we have to find this one, AB and BC. So let's see, first we go with this one. Okay, if we see these angles in the triangle, this triangle, let's say it's a K and it's a L. Okay, so in the angle, this K makes angle beta with angle of depression beta here. So with the triangle of law, we know that if angle of properties, we know if this angle is theta, then the beta, so this will be also a beta. So we know we got a beta, and this KL will be parallel to CD. So what if we get this KL, we can get this CD, CB also. Okay, because this is a parallel. So the relation between, and we, this is given, so actually we have to find this one, and for we have to find this also for because we have to get the relation between this one also. So relation between this base and this perpendicular is given by tan. So we simply write tan of alpha beta, sorry, uh, we can write tan of beta is equal to 60 by, let's say, LB, because this is the base perpendicular, this is a base, so LB. So if we see, we can write LB, whatever we calculated, equal to, just we do it, 60, just do the cross multiplication by tan of beta. And you know that 1 by tan theta is equal to cot theta. So this will be 60 into tan of beta. Okay. So this, you see this LB is tan of beta. So we got this KC will be also the tan of beta. Okay. So now, and this is 60 we know. Now we have to find AC. So we have to find relation between again this perpendicular and base. So this again use a tan alpha. So tan we go. Oh wait, it's really not good to write. So let's say I will use this one. Tan of alpha will be this perpendicular. So here perpendicular will be A of C, AC, and by this KC. And if you know, this KC is parallel to LB, so LB we already have. Uh, what LB we have? Actually, we made a problem. This actually this will be cot of beta, because CB. So this length of the tower will be, AC is this one, tan alpha into 60 cot beta, and this CB is 60. So this is the 60. Okay, so this is your answer. So with this, so this is our answer. So one thing we have to know this. So for solving this problem, we have to first read the question and we have to draw the diagram as per the question. Once the diagram is drawn, we will able to find what relation to be, what is the relation and what is missing. We have to find it. So we can easily find it with the help of this diagram, with help of diagram you draw. So I think I think it is clear to you. If you have any suggestion or any query, please put in the comment box. Thank you.